So we're finding the ordered pair which can be added to the set of ordered pairs so that the relationship would not be a function. Well, if you remember correctly, the domain cannot repeat, and the domain is your x values. So right now, we have 6, 1, and -5 as the domains. We just pick any ordered pair that has one of those. So for example, 6, 8 would make it not a function because the 6 repeats. Or we could use 1, 12 would make it not a function since 1 repeats, or even something like -5, 3, because that would make the 5 repeat. Any answer like that will work. Okay, so my cat's out there yelling. Sorry if you hear my cat yelling. Number 2, determine whether the relation is a function. Again, you're looking at all of the x values, the 5, the 8, the 7, and the 9. If we put those in a set, we would write it as domain is the set containing 5, and then you put them in order from least to greatest. So 5, 7, 8, and 9. And because none of those repeat, it's going to be a function. Number 3, determine the domain and the range of the relationship, or the relation, not the relationship. And we start out, we're looking at the x values, and remember the x is the domain and it goes right to left. So on this diagram, the domain is the bottom numbers. And your range go up and down, so that is your side numbers. So from our points, we look straight down for the domain, and that ranges between 1 and 3. So our domain is the set where 1 is less than or equal to x, which is less than or equal to 3. Our range, if we go from our point straight across, go from 10 to 30. So our range is 10 is less than or equal to x, which is less than or equal to 3. And actually, we probably should have put y there. So 10 is less than or equal to y, which is less than or equal to 30. Plumber X charges an initial fee of $39 for a home visit. So just coming out there, he's going to charge 39 bucks. After that, he's charging $33 per hour. So the plumber comes out for 1 hour. He gets $33 for that hour, and then he gets that initial fee of $39. So altogether, that's 33 plus 39, which is 72. If he comes out for 2 hours, he gets $33 an hour. So that's 66. Plus the initial 39, that gives him 66 plus 39, which is a total of 105. Now I'm going to fill the rest of the chart out. See how fast I was? Now we're going to look at the range and the domain, but according to the directions, it says n is less than or equal to 100, so we're looking from 0 hours to 100. So that's our domain. We write that as the domain n is less than or equal to 100. But our range is in relationship to the function. And the function is our equation. So we have to figure out what our equation is. So we took the number of hours times 33 and we added 39. So that was our total cost, and we're going to call it C for cost. Let's rewrite this as C equal 33N plus 39. Our range then is going to be C equal 33N plus 39. So in other words, your equation, where N is the element, that's what that little symbol is, element of the set of the positive integers less than or equal to 100. Find the slope for the given rise and run. Well, to find the slope is rise over run. So we put -3 in for the rise and put -9 in for the run. Negative divided by negative is a positive. So we get 3 over 9, which reduces to 1/3. So the slope is 1/3. Problem 6, find the slope of the line. Well, if you look, it's a horizontal line. And that should trigger something in your mind. And immediately you should know what kind of slope that is. But if you don't, put 2 points on that line. Figure out its rise. So how far up are you going from one to the other? Which is 0. You're not. And the run, we're going 1 unit from one to the other. So 0 divided by 1 is 0. So horizontal lines have a slope of 0. Number 7. Find the slope of the line that contains the given pair of points. If you remember correctly, to find a slope from 2 points, we use the letter M, and we go y2 minus y1 over x2 minus x1. So our y2 is 7, our x2 is 1, and minus our x1, which is 5, which gives us 0 divided by -4, which is 0. So that's going to be a horizontal line. Problem 8. Use the same formula. Our y2 is going to be 6 minus our y1, which is 5, over our x2, which is -7 and 1/5. But 1/5 is the same as 2/10, which is 0.2, 2/10. Then minus our x1, which is -4/5. But 4/5 is the same as 8/10, which is written as 0.8. 6 take away 5 is 1. -7.2 plus 6.8 gives us a negative 0.4. But you cannot have a decimal in a fraction, so we're going to multiply numerator n, denominator by 10. 10 over 4, because we just moved the decimal over once. Reduce that. And our final answer is -5 over 2. Problem number 9. The figure below represents the distance traveled from a car in 6 hours. Find the speed of the car. Well, the hours, if we go straight up at 6 to hit the line, and then we go over to the miles, the units over on the left side are by 20s. So that would give us 260 miles in 6 hours. Then to figure out the speed of the car, we just divide those out, which is 260 divided by 6, which is 4. Subtract that on out, and your answer ends up 44, so that's approximately 44 miles per hour. On number 10, you'll notice that the speed increases the first 3 minutes. So that tells you, since he's increasing, that he's going downhill. So he is going downhill for the first 3 minutes. Then his speed decreases. So that means he's going uphill, and that's from 3 to 7 minutes. So that would be 4 minutes. So he's going uphill for 4 minutes, and then he heads off in the level for, let's see, between 7 and 10 for 3 minutes.